Hello and welcome to Golden Droplets episode number 36. My name is Ricardo Valls. I'm the president and founder of Valls Consultant, and in today's episode we are going to be talking about the use of gradient in the interpretation of geochemical data. We'll show you some of the preliminary results that I got by using this simple Excel program, so we can identify quickly the locations of the most prospective areas in your project. So, once again, Golden Droplets, episode number 36. Enjoy! I will present here a simple method to quickly identify gradients areas that may be due to the presence of a true geochemical anomaly using Excel. A main limitation in geochemistry is that we never know for sure whether a low value of a gold sample is because there is no gold or because the source of the mineralization is too far away or too deep. In geochemistry, the actual value of a sample is not as important as its difference with other surrounding samples. This difference is known as gradient, a term more frequently used by the geophysicists. Let us see how the method works with this theoretic example. This slide shows a theoretic model to evaluate the method. It represents a hypothetical soil sampling composed of 11 profiles, each with 11 samples. Each sample represents the goal result of the soil sample taken at that place. We will be using Excel to process the data. This slide shows the data arranged by profiles and stakes on a spreadsheet, something like a matrix. At the center of the area, inside the bold square, there is a clear gold anomaly. We find the gradient between the sample by subtracting the gold value of each sample by the gold value of the previous one according to this equation. Of course, we are assuming that the profiles are perpendicular to the expected mineralization. Also notice that because of the procedure, we lost the first line of stakes for each profile. Using the stack column method as a graphic on this data, we can clearly see which profiles correspond to the geochemical anomaly. These are the ones that correspond to the geochemical anomaly because they are the biggest one, the difference from the rest. By reversing the data on the same model, we obtain this figure that shows which stakes contain the gold anomaly, which in this case are the smaller stack graphics. If we work with the absolute values of the data, we obtain more clear results. So I recommend that we work with the absolute values always. Let us complicate the model a little bit. I now move the mineralized zone to a corner from the center where it was before, and this is how the matrix looks for the grading going from south to north. And here are the results of the stack column graphics. Again, it's very clear to see where are the anomalous profile and the anomalous stakes. Let us see now a real case scenario. This map shows the location of a stream sediment sampling conducted over a gold target in Colombia. And this is the matrix of the data. I obtained this matrix by using Surfer, and the steps were first determining the variogram, then using kriging and the variograms to to do the kriging of the sampling, and then exporting the results of the kriging in the form of the matrix that you see here. This table shows the defined south-north gradient of this data, and this is the stack graphic for the same table. As you can see, these are the profiles that are the most interesting. We do the same, but in the west-east direction, and this is the graphic that we obtained, and we were able to locate these stakes and these group stakes as the most prospective one for the gold mineralization. Finally, we can see that the intersection of both gradients define the most anomalous gold values in the area. If we intersect this profile with these stakes, we get this square here that actually contains the highest gradient values for the whole area. Now, what will happen if we double the gridding? Instead of just using 1, we grid by 2. In this case, this is the matrix that we obtain for the south-north graphics, and these are the 2 profiles we select, and this is the matrix that we obtain for the east-west gridding, and this is the graphic that we obtain for them. This slide, as the previous one, shows the intersection of those 2 areas, and the square here shows the most prospective values for the gold mineralization. In conclusion, first, the gradient is more informative than the actual value of a sample. So I really recommend that we should work with the gradients, not with the individual samples in geochemistry. The gradient method allowed for a quick and easy location of prospective geochemical anomalies by using a matrix in Excel. It's very simple and very quick. A combination of the original gradients and their absolute values will provide the geochemist with an idea of where the anomalous values are spatially situated. This is like a very quick, very fast process to get an idea of where the anomalies are going to be. Finally, you can find online this paper just by clicking on this link here, or actually you can click on the image, a gradient method for identification of geochemical anomalies, and it will open your browser with this report. Okay, that is all for Golden Dot Press number 36, a gradient method for the interpretation of geochemical anomalies. As always, I welcome your comments and suggestions, and until next time, have a great day.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.